The first warning is not an explosion. It is a pause, the kind that spreads through a room before anyone admits they are afraid. In the Combat Information Center, the screens cast a cold blue light, and every face looks slightly submerged. Tracks do not arrive politely. They bloom all at once, dozens of symbols appearing, shifting, multiplying, like metal filings dancing on a magnet. Your mind tries to label them: drone, decoy, missile, noise. But the labels refuse to stick, because labeling costs time. And time is the one thing the swarm is stealing. You hear ventilation, distant machinery, and the tiny clicks of hands moving too fast across consoles. The air tastes dry and recycled, almost metallic. Someone says it might be interference. Someone else answers that interference is exactly what a swarm would bring first. This is BattleTech Declassified. Modern Warfare Explained. The captain does not ask how many interceptors you have left. He asks the question that makes the room feel smaller and the silence heavier. Do we still know what is real? Electronic warfare sounds like a technical appendix until you need it. Then it becomes brutally simple. It is the fight over perception. What your sensors believe, what your network repeats, and what your weapons obey. A swarm is not just a pile of drones. It is a decision loop. Detect, classify, track, assign, engage. If that loop stays clean, defense is math. If that loop is poisoned, defense becomes hesitation. EW attacks the loop in three broad ways. It can deny signals by drowning them in noise. It can deceive by injecting lies that look like truth. Or it can disrupt by breaking the links that let many drones behave like one organism. If air defense is the shield, EW is the hand that turns your head at the wrong moment. It does not need to destroy your weapons. It only needs to make your decisions late or wrong. Most people imagine a swarm as numbers. The deeper threat is ambiguity at scale. Not just many objects, but many possibilities attached to every object. With one inbound missile, a system can spend time becoming confident. With 50 inbound objects, confidence becomes expensive. Every second spent verifying a track is a second that disappears from your engagement timeline. Swarms can mix roles. Some drones carry warheads. Some carry jammers. Some are relays that keep the group connected across distance. Some are decoys designed to look more important than they are. That mixture forces choices. Shoot the loudest signal, the fastest object, the closest track, or the one that seems to be guiding the rest. The swarm wins when your attention bends under the weight of those choices. Jamming is the easiest form of EW to picture. You pour energy into a frequency band until the real signal cannot be heard, like trying to talk next to a jet engine. There are different approaches. Spot jamming targets one frequency. Barrage jamming covers a wide band. Sweep jamming moves across channels, hunting whatever the enemy is using right now. Jamming can protect you by weakening drone command links, navigation aids, or coordination channels. But it has costs. It is loud in the electromagnetic sense, and it can create collateral confusion because friendly systems live nearby in the spectrum too. Jamming is a hammer. Sometimes you need a hammer. The danger is swinging it so hard that you crack your own knuckles. Spoofing is not about shouting. It is about whispering a lie that sounds more believable than the truth. If jamming smears the window, spoofing replaces the view. A classic target is navigation. If a drone relies on satellite signals to know where it is, a stronger counterfeit signal can persuade it to accept the fake as reality. Now the drone's map is wrong, and it becomes harmless without understanding why. Spoofing can also target tracking and identification by creating ghost echoes, shifting positions, or distorting timing. It does not need to be perfect. It only needs to be believable long enough to force a bad decision. That is why spoofing terrifies professionals. It attacks trust, and once trust is cracked, every next decision becomes slower. A swarm behaves like one creature when its parts can talk. That conversation is the Datalink, the swarm's nervous system. Cut the nerves, and you may still have movement, but you lose intelligence. Some drones are human-controlled. Others follow a command node. a leader that pushes instructions. Others share information peer-to-peer, passing updates across the group like a rumor that spreads instantly. Those links can be jammed, intercepted, or overloaded. If the swarm cannot share targeting updates or timing cues, it risks breaking into individuals instead of arriving as one coordinated wave. But a broken link does not always mean a falling drone. Many platforms switch to fallback behavior. Hold course, continue last command, return to waypoint, or flip into autonomy. That fork in behavior is where EW either wins cleanly or creates a new problem. Sometimes EW delivers the cleanest kind of victory. You degrade coordination so thoroughly that the swarm loses its advantage without you firing a shot. This happens when the swarm depends on fragile synchronization. If drones need a command node to assign targets, or need continuous updates to maintain formation, denying those updates can turn a wave into scattered droplets. It also happens when the swarm depends on precise timing. If you distort navigation cues and spacing, the attack arrives out of rhythm. Instead of a simultaneous overload, defense faces smaller clusters that can be handled inside normal engagement capacity. The result looks boring on camera, but it is deadly in outcome. No fireballs, no heroic last burst, just a system that keeps working because the enemy's system stops making sense. The more EW succeeds, the more it pushes the opponent toward autonomy. Autonomy means the drone keeps executing a mission even when it cannot hear the network. A drone may navigate using internal sensors, follow pre-planned routes, or rely on onboard targeting near the endgame. When autonomy is solid, cutting the data link does not stop the drone. It removes the leash. Autonomy can be layered. A drone might use data link updates for precision, switch to inertial navigation when GPS is jammed, and then use vision-based cues close to the target. The design goal is simple. Keep moving, even when the sky is full of lies. In that world, EW becomes a timing tool instead of a kill switch. You might not stop the swarm, but you can degrade it, slow it, spread it, and force it to arrive less synchronized. Inertial navigation is how a drone can feel movement without listening to satellites. Accelerometers and gyros measure motion, and software integrates that motion into an estimate of position. The strength is obvious. GPS jamming cannot erase inertial navigation because inertial navigation does not depend on external signals. The weakness is drift. Over time, tiny errors stack up until the position estimate slides away from reality. EW can still matter by forcing drones to rely on inertial mode longer. The longer the drone must trust its inner ear, the more likely the swarm's timing and geometry degrade. A wave that was designed to hit from multiple angles at once becomes less clean. But drift is not a guaranteed savior. Modern inertial systems can be good, especially over shorter flights. And drones can blend inertial with other cues. EW may not make them lost. It may make them slightly less perfect, which can still buy seconds. Some drones do not need to be smart. They only need to be consistent. A pre-programmed route is a mission stored like a playlist. Fly here, turn there, descend now, impact the target area. This creates the zombie problem. You cannot confuse it by breaking a command link if it never expected commands. It follows the plan until it hits something or runs out of fuel. EW can still affect a zombie swarm, but the effect is usually indirect. You can jam sensors that refine the final approach. You can push it into fail-safes, climb, loiter, return, which changes density and timing. You can create uncertainty about where the target truly is. The uncomfortable truth is that physics can carry a drone far even when truth is missing. That is why EW is a layer, not a miracle. EW is not only about attacking the enemy, it is also about controlling your own emissions. Every time you transmit, you reveal something about your position, your posture, your priorities. In a swarm fight, this becomes a dilemma. Stay quiet and you are harder to find, but you may lose coordination speed. Radiate aggressively and you may jam the enemy, but you also light yourself up like a lighthouse in fog. The right answer depends on the network around you. If you have airborne sensors, satellites, or escorts feeding you data, you can afford to be quieter. If you are isolated, you may need to transmit more just to maintain a usable picture. The swarm tries to force a confession, make the defender show its hand. The defender tries to stay calm inside the storm, because calm is a resource too. Radar is echo listening. You send energy out, it bounces back, and you measure time, strength, and angle. EW manipulates that conversation. One method is denial. Add noise, so the echo becomes harder to interpret. Another method is deception. Create fake echoes, so the radar hears objects that are not there. In a swarm scenario, even small distortions matter. If a track wobbles, a weapon solution wobbles. If the system cannot hold stable tracks, it delays engagement or wastes shots on uncertainty. People imagine EW as total darkness. In practice, it is often smudged glasses during a sprint, and smudged glasses can still get you killed when seconds decide everything. The most dangerous lie in war is the one you want to believe. Under saturation pressure, you want the picture to simplify. You want extra tracks to be noise. You want weird behavior to be a harmless glitch. Spoofing exploits that desire. A ghost target placed near a real one can pull an intercept away. A false priority can make you spend a premium missile on a decoy. A fake pattern can force you to reassign weapons mid-flight. Even suspicion has a cost. Operators cross-check, request confirmation, delay commitment, not because they are weak, but because they are trained to avoid catastrophic mistakes. The swarm punishes that professionalism by closing distance while you verify. The swarm does not care if you are brave. It cares if you are late. EW is the craft of making you late. EW is not one button. It is a set of plays. You blend sensors, filter noise, validate tracks, harden links, and train people to recognize deception under pressure. Redundancy is the backbone. If one sensor is jammed, another verifies. If one band is noisy, hop. If GPS is unreliable, blend it with inertial and other cues. If a track looks too clean, demand corroboration before you spend your rarest interceptors. Defenders also manage escalation. You do not blast the spectrum continuously. You reserve power and techniques for the moment they matter most, when the swarm is close enough that timing becomes lethal. The goal is not perfect vision. The goal is vision that is good enough, fast enough, for long enough. Here is the clean truth about electronic warfare in the swarm era. EW can stop an attack without firing when the swarm depends on coordination, external signals, and clean timing. EW can fail when the swarm is built to keep moving, even when it cannot hear, even when it cannot see. So the real question is not, do we have EW? The question is, what does this swarm rely on? Every reliance is a handle, data links, navigation aids, command nodes, timing, and EW is the skill of grabbing the right handle at the right second. Next, we are going to walk those handles one by one, and we will watch how a smart swarm hides them, hardens them, or replaces them with autonomy. Because the blindfold is real, and the only question is who wears it first. On a calm day, the electromagnetic spectrum feels invisible, like air. In combat, it becomes terrain. Radios, radars, satellite receivers, data relays, even some fuses and seekers. All of it is traffic moving through an unseen city of frequencies. Electronic warfare is how you fight inside that city. Sometimes you block the roads with noise. Sometimes you reroute traffic with deception. Sometimes you cut the bridges so the enemy's system cannot stay coordinated. In a swarm fight, this matters because the swarm's strength is coordination. The more the swarm behaves like one organism, the more dangerous it becomes. If you can fracture that organism into isolated parts, the attack loses its timing, its geometry, and its intimidation. But the spectrum is also where your own systems live. When you fight in it, you are fighting in your own living room. Every move you make has a chance of knocking over your own furniture. People imagine jamming as flipping the lights off. In practice, it is often closer to turning a clean conversation into a crowded bar. You can still hear, but not clearly, and not reliably, and not without effort. That effort is the cost. When operators and algorithms have to work harder to confirm what they are seeing, timelines stretch. In a saturation scenario, stretched timelines are not just inconvenient, they are lethal. Jamming can reduce range, break track stability, and force systems to fall back to conservative behavior. Conservative behavior sounds safe, but it can mean slower engagement and fewer confident shots. And because jamming is loud, it can also invite a response. The enemy can detect the jamming source, adapt frequencies, change waveforms, or use it as a beacon that confirms where the defender is. A swarm is most terrifying when it arrives like a single wave. That wave is not accidental. It is planned timing. It is spacing. It is geometry. It is multiple approaches hitting your system at once so it cannot breathe. Electronic warfare can win without a dramatic shutdown by doing something subtler, breaking synchronization. If you force drones into delays, detours, loiter behavior, or inconsistent updates, the wave becomes a staggered line. That does not sound heroic, but it is survival math. A defender can handle small groups. A defender collapses when everything arrives together. If you can peel the swarm apart, you are buying seconds, and seconds are ammunition. This is why defenders often care less about perfect jamming and more about disrupting the attack rhythm. You do not need to erase the enemy's vision. You only need to ruin the enemy's choreography. Deception is powerful because it weaponizes the defender's caution. If a system cannot trust a track, it hesitates. If it hesitates, it loses time. If it loses time, it spends more costly interceptors to compensate, or it misses the window entirely. Spoofing can create false targets, shift perceived positions, or suggest that the most dangerous object is somewhere it is not. A decoy does not need to outrun a missile. It only needs to attract one. In a swarm, deception scales. One lie can produce 10 wrong choices. One false leader can pull attention away from the real threat. One ghost cluster can overload tracking resources that were meant for actual weapons. The cruel part is that deception often looks like nothing happened until the moment it is too late. When the defender finally realizes the picture was manipulated, the swarm is already inside the last slice of time where defensive choices matter. Satellite navigation is a common target because it is a shared dependency. If you deny it, you can degrade accuracy, disrupt timing, and force drones into fallback modes. But GPS jamming is not a universal stop button. Many drones can hold course without satellites for a while. Some blend multiple navigation inputs. Some use pre-planned routes that do not require continuous updates. The realistic benefit is often this: you create friction. You force uncertainty into the drone's own guidance. You push it toward less precise behavior. You may widen the dispersion of the swarm, and dispersion is breathing room for defense. There is also uncertainty here. Different platforms handle denial differently, and not all of those details are public. What we can say safely is that satellite denial can be significant, but it is rarely sufficient on its own against a swarm designed with redundancy. Inertial navigation is the drone's inner sense of motion. It uses onboard sensors to estimate position without relying on an external signal. That makes it naturally resistant to satellite denial. Its weakness is drift. Small errors accumulate into larger ones, especially over time and distance, so denial can still matter indirectly. If you push drones into inertial mode early, you increase the chance they arrive off pattern. But drift is not guaranteed to save you. Some systems are good enough for short missions. Some blend inertial navigation with other cues that reduce drift. Some accept good enough accuracy because saturation is their real weapon, not pinpoint precision. So the defender's mindset should be layered. Deny what you can, degrade what you cannot deny, and use the seconds gained to make the hard kill layers more efficient. A swarm that expects jamming can navigate like a person walking home in the dark. You do not need a map if you recognize landmarks. Some drones can use terrain contours, coastlines, or visual features to confirm where they are. This is why electronic warfare is not only about radios and satellites. The goal is to disrupt the full guidance story. If the drone uses vision, then smoke, obscurance, decoys, and signature management become part of the same fight for perception. Not all swarms have this sophistication, and we should be honest about that uncertainty. Capabilities vary widely, but the direction of travel is clear. The better the autonomy, the less a swarm depends on clean external signals. That is why defenders cannot build a plan around one denial technique. The swarm will eventually learn to step around it. Many swarms rely on a leader, a command node that assigns roles, shares targeting updates, and keeps timing tight. If you can isolate or mislead that node, the entire formation can lose coherence. This is a place where electronic warfare can be brutally effective. If the leader cannot talk, the swarm becomes a crowd. If the leader receives lies, the swarm becomes misdirected. But the enemy knows this too. A smart swarm can distribute leadership, rotate command roles, or use multiple relay nodes so the attack does not collapse when one throat is squeezed. So the defender must treat command nodes as high-value targets, but not as a single point of salvation. It is a lever, not a guarantee. When the picture becomes noisy, defenders lean on correlation. Correlation means checking one sensor against another, one track source against another, one timing estimate against another, to see what remains consistent. A simple example is this: if radar shows a track but infrared does not, caution increases. If multiple sensors agree, confidence increases. If a track behaves in an unnatural way, too perfect, too symmetrical, too convenient, suspicion increases. This is where training matters. Humans are pattern detectors, but under stress, they can also become pattern inventors. The best teams practice recognizing deception cues without freezing. Filtering is never perfect. The goal is not to eliminate doubt. The goal is to keep doubt from paralyzing the timeline. Fighting in the spectrum is like using smoke in your own hallway. It can hide you from an intruder, but it can also make you stumble. Aggressive jamming can interfere with friendly communications, navigation aids, or sensor fusion. It can increase the workload on your own operators as they compensate for the noise you introduced. This is why real-world doctrine often prefers controlled, targeted use rather than continuous blasting. You save power for critical windows. You choose techniques that shape the battle rather than blanket it. The harsh truth is that a defender can drown in its own countermeasures if it panics. In a swarm fight, panic is a faster killer than the first drone. One of the swarm's smartest tricks is to make you spend premium interceptors on cheap objects. Deception helps it do that. If a decoy looks like a warhead, you treat it like one. A ghost cluster can do the same. If your system believes 10 threats exist, it allocates resources as if 10 threats exist. Even if only 5 are real, the allocation is still costly. This is where electronic warfare and ammo economics meet. Deception is not just about confusion. It is about draining magazines, draining attention, draining the time you need to reload your decisions. The goal for defenders is disciplined skepticism, not denial, not wishful thinking. Disciplined skepticism that preserves resources without turning every decision into a committee meeting. A swarm can probe. It can send small groups to see how you respond, what sensors light up, what frequencies you jam, what weapons you prioritize. Each response is information. A defender who reacts loudly can reveal preferences and thresholds. A defender who reacts predictably can be shaped. The swarm can adjust timing and angles to arrive when your system is most strained. This is why modern defense tries to avoid being readable. It varies its responses. It uses decoys of its own. It sometimes holds fire, not out of weakness, but to avoid revealing the rhythm the swarm wants to exploit. There is uncertainty here too. Public details on exact techniques are limited, but the principle is stable across warfare. Probing is common, and predictable systems get punished. A realistic promise of electronic warfare is often 3 verbs: degrade, desync, disrupt. Degrade the quality of the swarm's information. Desync the timing that makes it overwhelming. Disrupt the links that let it behave like one. If you achieve those 3, you are not guaranteed safety, but you turn a catastrophic timeline into a manageable one. You turn a flood into a sequence of waves. You turn fear into process. This is where the listen-first reality lands. You rarely hear the moment electronic warfare works. You notice it because the room stays functional. The callouts stay short. The tracks stay trackable. The timeline stays breathable. In a world obsessed with explosions, the quiet win is the most valuable win. The nightmare scenario is not jamming failure. It is jamming success that triggers autonomy across the swarm. And now every drone continues inbound without needing to listen. In that case, denial does not remove the threat. It removes your ability to influence it through the spectrum. The swarm becomes less coordinated, but still deadly, especially if the plan was always to saturate you with numbers rather than precision. This is where defenders must be honest. Electronic warfare is not a substitute for hard kill layers. It is a layer that can buy time and reduce density. But you still need guns, missiles, and close-in systems ready for what survives the fog. The goal is never to bet everything on one layer. The goal is to make every layer cheaper, faster, and more likely to succeed. There is a moment in every saturation event when the room changes. Voices get quieter. Movements get more deliberate. The team stops talking about possibilities and starts talking about actions. That moment often arrives when electronic warfare has done its job. Not perfectly, but enough. Enough to separate the wave. Enough to strip coordination. Enough to make the tracks behave like physics again, instead of like a trick. And it can also arrive when electronic warfare fails, when the swarm keeps coming clean and confident through the noise, when fallbacks and autonomy keep it moving as if your denial never happened. Either way, the same truth remains. In a blindfold war, the decisive question is not what you can see, it is what you can trust, and how long you can keep that trust alive before the swarm reaches the final seconds. In modern defense talk, soft kill means stopping a threat without physically destroying it. Hard kill means you destroy it with a weapon. Electronic warfare usually lives in soft kill territory. It tries to make the threat miss, quit, drift, or lose coordination. Soft kill is attractive because it can scale. A jammer can affect many drones at once. A deception technique can waste multiple enemy decisions with one lie. Hard kill is expensive and limited. Every interceptor fired is one less in the magazine. But soft kill has a weakness. It relies on the enemy still caring about information. If drones fall back to autonomy, soft kill becomes less decisive. Then hard kill must finish what the spectrum could not. The practical doctrine is not soft instead of hard. It is soft first, hard last. Soft kill is the bouncer at the door. Hard kill is the last person in the hallway with a bat. The best defense uses both, in the right order, with no illusions about either one. When a swarm is inbound, the room wants answers. The best teams narrow everything down to two questions. First, what does the swarm rely on? Second, what happens when we take that reliance away? If the swarm relies on data links, denial can fracture it. If it relies on satellite navigation, denial can disrupt timing and geometry. If it relies on a command node, isolating that node can turn orchestration into chaos. But the second question is where teams survive. If denial triggers autonomy, you did not remove the threat. You changed its behavior. If denial triggers return to base failsafes, you may have bought safety. If denial triggers loitering, you may have created a second wave later. These questions sound simple, but they are hard under pressure because pressure tries to make you do something, anything, now. The discipline is to act, but act with a model in your head of how the enemy reacts to your action. An enemy does not have to defeat your jamming. It can dodge it. Frequency hopping means the signal rapidly changes channels, so it is harder to jam consistently. Think of it like trying to clap along to a rhythm that changes every beat. Some systems also use spread spectrum techniques, which smear the signal across a wider band so it looks like noise unless you know the pattern. That makes targeted denial harder, and it forces the defender to choose between broad jamming that risks collateral effects or narrow jamming that may miss. There is uncertainty here because the exact implementations are not always public, but the principle is stable. If electronic warfare becomes a major threat, the attacker invests in resilience, and resilience means fewer single points of failure in the swarm's communication story. This is why defense cannot rely on one trick. You build a toolkit, you test assumptions, and you accept that the enemy will evolve. In a swarm era, adaptation is not a bonus. It is oxygen. A ship that fights alone is easier to confuse. A ship inside a network has more ways to cross-check truth.
Airborne sensors, satellites, escorts, and other ships can provide alternate views, alternate tracks, and alternate timing estimates.
This matters in electronic warfare because deception often works by isolating a single perspective. If only one sensor sees a target, it might be a ghost. If multiple sensors agree from different angles, confidence rises. The network does not eliminate deception. It reduces the chance that a single lie becomes the whole truth. It also spreads the workload, so one ship is not forced to process the entire storm alone. Of course, networks have vulnerabilities too. Links can be jammed, intercepted, or degraded. That is why robust defense designs multiple paths for information and trains crews to operate when the network is partial. A network is a strength, but only if you can still fight when it breaks.
There is always a moment when someone asks whether to turn up emissions. More radar energy, more jamming, more transmissions. It feels like turning on headlights in fog.
You might see more, but you also announce yourself. Electronic warfare in that moment is a trade. If you radiate early, you may disrupt the swarm sooner. If you radiate late, you preserve stealth, but risk being surprised inside the last minutes. Good teams treat radiation like spending money. You do not empty the wallet in the first minute. You spend when the purchase matters, when the swarm is at a range where denial can meaningfully desynchronize the attack, and when you can combine it with other layers. There is no perfect rule, because context changes everything. Weather, sea state, supporting assets, threat type. The best you can do is build doctrine, drill it, and then stay flexible when reality refuses to match the checklist. Electronic warfare is technical, but the suffering it creates is human. A noisy picture makes people doubt themselves. Doubt leads to slower calls. Slower calls compress the engagement window, and compressed windows make everyone harsher, more blunt, more exhausted. Teams fight this with training and roles, short callouts, clear authority, predefined thresholds for action. If you debate every track, the swarm wins. If you blindly trust every track, the swarm wins too. This is why good crews practice uncertainty. They practice operating with incomplete data, and they practice saying, "We do not know, but we must act anyway." That sentence is uncomfortable, but it is honest. In many real events, what separates survival from catastrophe is not the fanciest hardware. It is whether the people in the room can keep the timeline from collapsing while the spectrum tries to pull them into confusion. Deception rarely announces itself. It whispers. The clues are often small. Tracks that appear too perfectly spaced. Targets that move with unnatural consistency. Clusters that show up exactly where you would least like them to be, like a story written for maximum panic. Another clue is mismatch. One sensor insists, another disagrees. Timing is off. Range estimates wobble. The picture feels busy, but not coherent. That feeling is not proof, but it is a signal, your brain noticing friction between expected physics and presented data. Defenders use these clues to decide where to focus verification. They do not have the luxury to verify everything. They verify what matters most. And they assign skepticism like a resource. This is where electronic warfare becomes a duel of pattern recognition. The attacker tries to craft believable lies. The defender tries to detect the lie without wasting the entire timeline doing detective work. It is tempting to imagine a perfect spectrum shield, a clean bubble where enemy signals die and friendly signals thrive. In reality, the spectrum is messy, dynamic, and contested. Electronic warfare techniques depend on distance, geometry, power, frequency, environment, and the enemy's countermeasures. A method that works at one range may fail at another. A method that works against one drone type may fail against another. This is why doctrine focuses on probabilities, not certainties. You aim to reduce the swarm's effectiveness, not to guarantee collapse. You aim to buy time and reduce density. Then you let the hard kill layers exploit that advantage. When leaders promise flawless denial, they are selling comfort, not reality. Real defense is uncomfortable. It is a set of imperfect tools used with discipline, under pressure,
against an enemy who is trying to learn your habits.
The most valuable outcome is often not the swarm stopped. It is the swarm arrived wrong. Wrong timing, wrong spacing, wrong approach angles, wrong confidence.
If electronic warfare can break the wave into multiple smaller moments, the ship's systems can breathe. Tracking resources are not overloaded at once. Interceptors are allocated with less panic. Close-in systems face fewer simultaneous threats.
This is the kind of win that never trends on social media. It is not cinematic. It is procedural. The team runs the checklist, the system stays stable, and the ship lives. In a saturation era, survival is often a collection of small, boring successes stacked on top of each other, until the timeline ends and you realize you are still afloat. There will be scenarios where electronic warfare does not deliver the effect you want. The swarm is too autonomous. The guidance is too redundant. The deception is too believable. The environment is too noisy. Supporting assets are absent. In those moments, defense becomes raw timeline management. You accept that the picture is imperfect, and you choose actions that preserve the most critical resources, weapons, attention, and time. You also accept uncertainty. You do not pretend you have full truth. You make decisions with incomplete truth, and you commit to them, because indecision is the one mistake that always grows worse with time. This is not pessimism. It is realism. Realism is the emotion that keeps people alive when optimism runs out. A practical sequence often begins with diagnosis. What signals are present? What is jammed? What is suspicious? What looks physically plausible? Crews lean on correlation and on pre-briefed threat libraries, known patterns of drones, decoys, and jammers. Then comes targeted denial. Not everything, not everywhere, but the links and cues most likely to fracture coordination. If the swarm seems networked, pressure the data links. If navigation cues appear critical, pressure them. If a leader node seems present, isolate it. While that happens, defensive layers prepare for what survives. Hard kill systems are readied with clear priorities. Close-in systems are placed in the best posture for sudden, dense arrivals. The team does not assume soft kill will be enough. The playbook is not glamorous. It is triage. It is calm. It is treating the spectrum like a knife fight, where you win by not bleeding faster than you can think. One of the most dangerous effects of electronic warfare is friendly confusion. If your own networks degrade, if your own sensors disagree, if your own countermeasures interfere with your own tracking, you can end up fighting your own picture. That is why disciplined emissions and disciplined procedures matter. You must know what you turned on, why you turned it on, and what side effects to expect. Otherwise, you create noise, then mistake your own noise for the enemy's deception. The swarm does not need to be technically superior if it can push you into self-inflicted disorder. A panicked defender can waste missiles, double assign targets, or delay critical engagements simply because the room stops sharing one coherent story. In the end, the swarm is not only a hardware threat, it is a stress test. It tests whether the defender can remain a team when information becomes unreliable. There is a thin line where a battle shifts. On one side, the system is still in control. Tracks are manageable. Decisions are paced. Resources are allocated with intent. On the other side, the system is reacting, chasing, improvising, spending without thinking. Electronic warfare is often the hand pushing you toward the wrong side of that line, not by destroying your systems, but by adding enough friction that your timeline compresses and your confidence collapses. The defender's job is to protect the line. Protect it with redundancy. Protect it with training. Protect it with conservative discipline when the picture is unstable. Protect it by using soft kill to reduce density and by reserving hard kill for what cannot be influenced. If you hold the line, the swarm becomes a solvable problem. If you lose the line, the swarm becomes a cascade. When people imagine future naval battles, they picture missiles and fire. But the fight often begins earlier, in quiet rooms, under blue light, where the first casualty is certainty. Electronic warfare turns combat into a contest over trust. Trust in the sensor picture, trust in the network, trust in the decisions you make with incomplete information. The swarm tries to break that trust, not because it enjoys confusion, but because confusion is a weapon that scales. And here is the uncomfortable conclusion forming. If the attacker builds autonomy and redundancy, denial alone will not save you. If the defender relies on one miracle technique, it will eventually fail. The winning approach is layered. Degrade the swarm's coordination, desynchronize its timing, then destroy what survives with hard kill systems that are not overwhelmed. In the last segment, we bring it home, not with a fantasy of perfect control, but with the real lesson that keeps ships alive in a blindfold war. In the Combat Information Center, you never get full truth. Not in a swarm fight. You get enough truth to act, and you get it just long enough to survive. Electronic warfare is powerful because it can stop a swarm without firing when the swarm depends on coordination, external signals, and clean timing. It is dangerous because it can also fail when autonomy, inertial navigation, and pre-programmed routes keep the drones moving through noise like they were built for darkness. So the lesson is not to worship the blindfold, and it is not to fear it. The lesson is to treat the spectrum as a battlefield, where your goal is not perfect vision, but usable trust. You degrade, you desynchronize, you disrupt, and you use the time you buy to let the rest of your layered defense do its job. Because in the end, the swarm does not win by being invisible. It wins by making you hesitate. And the defender survives by acting with discipline, even when the picture is smudged, even when the room is quiet, even when the only honest answer is, we do not know everything, but we know enough to fight.